Hello everyone. So in this session, I'm going to discuss all the questions based on number system, and it includes base system also. Right? Some of the question based on base system has been appeared in Z. We'll discuss those also. All the question from 2010 to 2018. Okay, so let's start. So I'm starting with Z 2010. The question says, let x be a four-digit positive integer such that the unit digit of x is prime. It's a four-digit positive integer and the unit digit is prime. And the product of all the digits of x is also prime. The product a into b into c into d, it's also prime. How many such integers are possible? So there's a four-digit number and the unit digit is prime. If this number is prime and the product is also prime, how it can happen? It can happen when the other three digits are 1. Only then the product can be prime, because if you multiply any prime with any other digit, this number cannot be prime. So this is only possible when the other three digits are 1 and this digit is prime. And this digit has to be a single digit prime. So single digit prime are 2, 3, 5 and 7. So how many such numbers are possible? Only 4 numbers are possible, because these three digits cannot be anything else except 1. So these are the only 4 numbers. Okay, so that was an easy question, should be done within 30 seconds. This digit is prime and the product is also prime, only possible when the other three digits are 1. Okay, option 1 is the answer. Come to the next one. Now it says A, B, C, D, E are integers such that A can be equal to 1 or greater than 1, B is greater than 1, C is greater than B, B is greater than A, C is greater than B, and so on. A, B, C, D, are E are geometric progression, and LCM is the least common multiple of M and N. Then the maximum value 1 upon LCM, 1 upon LCM, 1 upon LCM, so on. Now we know if you want to maximize it, when it will be maximized? It will be maximized when the denominator is as minimum as possible. So we need to take the small values of A and B. Only then the fraction will be maximum. Now it is geometric progression and they are integers. So obviously I can take the common ratio as 2, 3, 4, so on. But if I take to make it, if I want to make it minimum, obviously I'll take the common ratio, which is R, as minimum as possible, which is 2. And I can start the smallest number as 1. So what can be the smallest 5 numbers? The smallest 5 number which are in GP can be 1 into 2 into 2 into 2 and into 2. This is the smallest 5 number which can be in GP, right? So what is the LCM of 1 and 2? 1 and 2 ka LCM, it's 2. What is the LCM of 2 and 4? The LCM of 2 and 4 is 4. And similarly the LCM of 4 and 8 is 8, and LCM of 8 and 16 is 16. So that is the maximum value of the fraction. So that comes out to be 16. 8 plus 4 plus 2 plus 1, and that is the answer. Answer is 15 by 16. You cannot make it more than that answer, not possible. If you take 3, the number will be obviously greater. Options are given 81 also. So if I try to take it 81, so it will be 1 by 3, 1 by 9, 1 by 27 and 1 by 81, and that obviously will be less than 15 by 16. You can check it. 27 plus 9 plus 3 plus 1, that will be 36. 36 plus 4 is 40 by 81, which is not even half. That is even less than half. So that cannot be maximum. The maximum value is 15 by 16. Option B. Come to the next one. To the next one. Next question says a chocolate dealer has to send chocolates of 3 brands to a shopkeeper. All the brands are packed in the boxes of the same size. The number of boxes to be sent is 96 of brand A, 240 of brand B, and 336 of brand C. These boxes are to be packed in the cartoons of same size. So the boxes has to be same size, containing equal number of boxes. Containing equal number of boxes. Each carton should contain boxes of the same brand of chocolate. So each carton can have only same brand. What could be the minimum number of carton that the dealer has to be sent? So if you want to minimize, we try to put it as maximum as possible number of chocolates in a box, and that number has to be equal. So what is that number in which 96 can be divided? What is that number in which 240 can be divided? What is that number in which 336 can be divided? Which is nothing, which is the highest common factor of these three numbers. So basically in this question, first we need to find the HCF of these three numbers, because only then I can divide 96 in that number, I can divide 240, I can divide 336. So if I factorize it, that is 24 into 4, that is 24 into 10, and that is 24 into 14. Can I take something more common? Yes, I can take it something more common. So can I say it as 24 into 2 into 2? That is 24 into 2 into 5, and that is 24 into 2 into 7. So basically the highest common factor is coming out to be 48, which is available in all the numbers. I cannot take more common from 2, 5 and 7. So what is the HCF? HCF is 48. It means I can put 48 boxes or 48 chocolates in a particular box, right? So how many boxes are required of brand A? If I put 48 chocolates in a box, how many boxes are required? 2 boxes. How many boxes are required? 5 boxes. How many boxes are required? It's 7 times. So 14 boxes or 14 cartons are required minimum. Right? So first we find the HCF, and then we find out number of cartons. Number of cartons can be 2 of brand A, 5 of brand B, and 7 of brand C. So total 14 cartons required. Okay. From the next one. AN is 1111 written n number of times. We need to find out that A741 means A is written 741 is a prime or not a prime. Now first you should know a rule that any number written composite number of times cannot be prime. Any number is written composite number of times can't be prime. Means any number written 10 times cannot be prime. Any number written 12 times cannot be prime. Right? And even if it is written prime number of times, then also we can definitely not say it is prime or not. Look at here. 111 is written 741 times. So it is a prime or not? What is 7 plus 4 plus 1? 7 plus 4 plus 1 or 741 is 12. So if you write 111 740 times, 741 times, the sum will be 741, and 741 is a multiple of 3. 741 is 12. For 3 you know the rule, sum of the digit. So it becomes 12, and 12 is divisible by 3. So 741 is not a prime number. So 111, if we write 741 times, it will be divisible by 3. If it is divisible by 3, it cannot be prime. So it's not a prime. Yes, it's not a prime. It's a correct statement. So look at here. 5 plus 3 plus 4. Again, it makes 12. So 111 in 534 times. Again, it will be divisible by 3. 534. 534 is divisible by 3. So sum will be 534. 534 is divisible by 3. So this number cannot be prime. That is also true. 123 is not a prime. That is also true. 1 plus 2 plus 3. 77. Now 111 is written 77 times. Now, what did I say? 111 is written composite number of times. 77 is a composite number of times. So this number B cannot be prime. You need to remember this rule. I'm not going into detail of that rule right now because we are just discussing the question, not the rule. So for the timing, you can just remember that any number written composite number of times cannot be prime. So that is also true. So what is the option? It's not a prime, it's not a prime, it's not a prime, it's not a prime. Yes, all of them are correct statement. None of them it's a prime. All of them are correct. So what is the answer? Answer is the fourth one. Okay, come to the next one. Now that is Z 2012. Lionel and Ronaldo had a discussion on the ages of Joe's sons. Ronaldo made following statement about Joe's sons. Joe has three sons. That is the first statement. The sum of the ages of Joe's sons is 13. The product of the ages of the son is the same as that of Lionel. Now, if nothing is given about Lionel, I do not think we can use this information. Joe's eldest son, Jijou, weighed 32 kilos. That is related with the weight. So again, I do not think I need to use this information. The sum of the ages of the younger son of Joe's is 4. Joe's has fathered a twin. So that he has his twin children. Joe's is not the father of a triplet, so he doesn't have a triplet. The LCM of the ages of Joe's sons is more than the sum of their ages. Okay. Which of the following combination gives information showing you to determine the ages of Joe's sons? So in this question, you can try the options. Let's say if I use first, second, third, and fourth information. First information, he has three sons. Second information, the sum is 13. The product is same as Lionel. So obviously I do not know, many combination are possible. Product is equal to the Lionel, but we do not know the age of Lionel also. So many combination. Joe's eldest son Jijao weigh 32 kilos. So obviously nothing to do with the weight. So we cannot find the answer by using third and fourth condition. So definitely you can eliminate all the option which is giving you third hint or fourth hint. So I can eliminate this is giving me third hint, no use. This is giving me the hint, four hint, no use. I left with fourth option or fifth option. If I use the fourth option, which is giving me first, second, fifth, and seventh. If I use the fifth information, the sum of the ages of the younger sons of Joseph is 4. Now, fifth information. First and second we have already used. 3 sons. And second information, sum is 13. Now, if sum is 13 and fifth information says that the two younger sons' age is 4. So let's say two younger sons are A, B, and C and their ages is 4. So third has to be 9 because total is 13. But still I'm not able to find out their exact ages because 1 and 3 is a possible combination and 2 and 2 is also a valid combination. So right now I'm not able to get the answer. Two possible combination. Look at the seventh information. Jose is not the father of a triplet. Jose is not a father of the triplet. So in both the cases, it is not a father of a triplet. So again, it is not giving me any further information. So seventh also not giving me a further information. So this is of no use. But look at this. First, second, fifth, and sixth. Instead of seventh, if I use the sixth information, it says Jose has fathered a twin. Now, if Jose is a father of twin, I can get the answer. The ages will be 2, 2, and 9. So by using first, second, fifth, and sixth condition, we can get the answer, not with any other combination. So that is the correct answer. So easy question. If you put it all the information in a sequence, you can go through very easily. Do not confuse that how to use all the information. We need not use all the information. Okay, come to the next one. A number is interesting if on adding the sum of the digit of the number and the product of the digit of the number, the result is equal to the number. What fraction of the numbers between 10 and 100? Now 10 and 100, including both the numbers, if I ignore this 100, can I say all the numbers from 10 to 99, there are two-digit number? We'll check again for 100. But first look at all the two-digit number. Two-digit number, we write it in this way, 10x plus y. xy is a two-digit number, so we say it is 10x plus y. What is saying? It is saying if I add the digits, adding the sum of the digits of the number and the product of the digits, x plus y plus x into y, this gives me exactly the same answer as equal to the number itself. That is equal to 10x plus y. But y is cancelled. So it comes out to be 9x is equal to x into y. X is again cancelled, so y should be 9. If y is 9, and obviously it is a two-digit number, so x can take all the values from 1 till 9, x cannot be 0. So how many two-digit numbers are possible? 9 two-digit numbers are possible in this scenario. But we need to check for 100 also. Is it possible if I add the digits of 100 with the product of the digit, is it equal to the number itself? No, it is not. That is 0, that is 1, that is not equal to the number itself. So how many such numbers? 9 such numbers. And how many total number from 10 to 100? 91. What fraction of the numbers are satisfying this condition? It's 9 by 91. 9 by 91, it's not 0.10. It is less than 0.10, and there are all the option which is more than 0.10. So answer is none of these. It is less than 1 by 10 now, and no option is less than 1 by 10. So answer is none of these. Straight away. Easy question. Come to the next one. Now this question is a base system question. Consider the expression xx in base b, that is in base b, that is equal to x cube, where b is the base, x is any digit of base b, find the value of b. Now I'm sure you know the rule how to write it in base 10, that is given in base 10. So how to convert any number from base b to base 10? We multiply with the power of this base with that digit. So we write it x into b square plus x into b raised to power 1 plus x into b raised to power 0. That number is converted to that 10 base. That is given equal to x cube. Now can I take it x common? If I take x common, I'll get b square plus b plus 1, that is x cube. So my question becomes b square plus b plus 1, that is equal to x square, because 1x will be cancelled. That is my question. Now if you know that in a particular base, the digits which we can write has to be less than the base. Suppose if the base is 5, I cannot write 5. I can write maximum till 4. So that b जो base है, that should be greater than the digit. So ये बताओ, अगर base बड़ा है तो b स्क्वायर तो यहाँ पर भी है और यहाँ पर x स्क्वायर है, और ये नंबर बड़ा है, अगर b x से बड़ा है तो b स्क्वायर प्लस b प्लस 1 कभी x स्क्वायर के बराबर हो सकता है? अगर x बड़ा होता, ये डिजिट बड़ी होती, तब तो b स्क्वायर प्लस b प्लस 1 x स्क्वायर के बराबर हो सकता था, बट ये खुद ही बड़ा है तो b का स्क्वायर यहाँ पर है, तो ये डिजिट तो खुद ही आपस में इससे बड़ी हो गई, उसमें कुछ और ऐड हो रहा है, ये कभी x स्क्वायर के बराबर हो सकता है? नहीं हो सकता. यानी कि ऐसा कोई बेस ही पॉसिबल नहीं है जिसमें ये ऐसा होगा. सो आंसर स्ट्रेट अवे क्या आ गया? आंसर आ गया नन ऑफ द अबव. नन ऑफ द बेस विल सेटिस्फाई दिस कंडीशन. पॉसिबल ही नहीं है, तो सॉल्व करने की जरूरत नहीं है, होगा भी नहीं. आंसर इज नन ऑफ द अबव बिकॉज दिस इज नॉट पॉसिबल. यू कैन ट्राई ऑप्शंस आल्सो, इट विल नेवर सेटिस्फाई. ठीक है, कम टू द नेक्स्ट वन. Again, it's a base question. Two numbers, 297b in base b and 792 in base b belongs to base b in the number system. If the first number, this number, is a factor of this number, then the value of b. Now if I simplify this number is 2b square plus 9b plus 7. and this number is 7b square plus 9b plus 2. So the question says this number is a factor of this number. It means this number is a multiple of this number. So now, as nothing else is given, so in this question you cannot do anything else except putting the options. This number should be multiple of this number. Now use options. Let's say b is 11. So if I take b is 11, look at the first number. That is 7 into 11 square plus 9 into 11 plus 2. That is 121 into 7. That is 847 plus 99 plus 2. That is 101, so 948. And what is 2b square plus 9b plus 7? That is 106 and 242. That is 348. Is it a multiple of 948? Is a multiple of 348? No, this is not satisfying. Similarly, you will try for 12. Similarly, you will try for 15. Later on, the only option which will satisfy is 19. So once you put 19, that will satisfy this answer. So no other way. You will just put the value in from the options in these two equations and check which value is satisfying. Only 19 will satisfy. That is the answer. Simple question though. Come to the next number. An ascending series of numbers satisfy the following conditions. When divided by 3, 4, 5 or 6, the number leaves a remainder of 2. A number when divided by 3, 4, 5 or 6, the numbers leaves a remainder of 2. All the numbers is leaving a remainder 2. When divided by 11, the numbers leaves no remainder. The sixth number in the series will be. Now we need to find out all the number which is satisfying this condition. So the smallest number which leaves the same remainder is the remainder itself. The smallest such number is the remainder itself, 2. 2 when divided by 3 will leave remainder 2. 2 when divided by 4 will leave remainder 2. The next number you will get it after adding the LCM. Normally in books, this number is giving as the smallest number. This is not the smallest number. This is the second smallest number. That is the next number. The smallest number is 2. So LCM is 6 into 5 into 2, 30. 6 into 5 into 2, 60. So I'll add some multiple of 60, and after adding 2, this number will satisfy this condition. All the number of this series will satisfy. 62 will satisfy, 122 will satisfy, and so on. But this number should be divided by 11. So this number should be a multiple of 11. We are looking for that particular number. So find the value of n such that we get an integer value. So if I put it 1, 62, no, it will not be an integer. If I put it 2, 122, it will not be an integer. If I put it 3, 182, again not an integer. But if I put it 4, I'll get an integral value. So the smallest number which is satisfying this condition, it's 242. So 242 is the smallest number which is divisible by 11 also. And once you get the smallest number, we need to find the sixth such number. That is the smallest number. That is the first such number. It's 242. Can you tell me the second such number? Second such number you will get it after adding the LCM of all the numbers 3, 4, 5, 6 and 11. That is the second such number. So what is the LCM of? You have already find the LCM of these numbers, which is 60. So take the LCM of 60 and 11, which is 660. So add 660 in these numbers to get your desired number. So if you want to get the sixth such number, I'll get 660 5 times into 42. That is my sixth number. So 3300, 35, 42 will be my sixth such number straight up. That is my answer. So once you get the smallest number, that is 242, the next number will be after adding the LCM of all the numbers. So what is the LCM of all the number? LCM of these number we have already got it 60. 60 and 11 का LCM 660. So add करते जाओ 660 number आते जाएंगे सारे. So smallest number, second smallest number, third smallest number. We need the sixth smallest number. So add 5 times. Done. Come to the next one. Let's say the 3-digit number has digits in strictly descending order. Strictly descending order means A is greater than B, B is greater than C. And divisible by 10. Number will be divisible by 10 if this digit is 0. So C is 0. By changing the places of the digits, a new 3-digit number is constructed in such a way that the new number is also divisible by 10. So if new number is divisible by 10 and again it is a 3-digit number, so obviously this digit cannot be 0, because if this digit is 0 and this digit is 0, and if I interchange these two digits, number is in descending order, so these two digits cannot be same. And number is still divisible by 10, so we have not changed the place of this number, we have just changed the place of these two numbers. So now the new number becomes BAC. After changing the digits of these two places, number is still a multiple of 10. The difference between the original number and the new number is divisible by 40. Now, what is the original number? Original number is 100A plus 10B plus C. And what is the new number? New number is 100B plus 10A plus C. The difference between the original number and the new number is multiple of 40. Which number is large number? This number or this number? A is greater than B, na? Digits are in descending order. So if A is greater than B, this number has to be more than this number. So if I subtract this number from this number, I'll get 90A minus 90B. That number should be multiple of 40. How many numbers will satisfy this condition? Now if this number is a multiple of 40, so A minus B definitely should be 4. Then only it will become multiple of 40, 360. No other number will satisfy. 19 to 2, and one more possibility, 19 to 8. That is 720. So we get to know that A minus B can be 4 or A minus B can be 8. Two possibility. How many numbers? 9 minus 5, 8 minus 4, 7 minus 3, 6 minus 2, 5 minus 1. I cannot take 0 here. 4 minus 0 I cannot take, otherwise it will be a 2-digit number. So 5 such number here and only one number here. I cannot take 0 again. So how many such numbers? There are 6 such numbers. So there is basically based on digits and digits reverse based question. We normally do it in simple equation. I have included this number in the numbers part. It's kind of numbers based question. So 6 such number. Go to the next one. Again a base system. As you can see, there are plenty of questions which are based on base system. Two numbers 2061, that is in B base, 601 also in B base. The sum of these two numbers in decimal system is 432. So if you simplify, this comes out to be 2b cube plus 6b plus 1. And if you simplify, this comes out to be 6b square plus 1. And sum of these two numbers is given as 432. So 2b cube plus 6b square plus 6b plus 2 should be 432. Or I can say b cube plus 3b square plus 3b plus 1, that should be 216. If you can notice, this is nothing, it is b plus 1 whole cube. B cube plus 1 plus 3b square plus 3b1 square. That is 216. That is 6 cube. So b plus 1 is 6. So b comes out to be 5 base. If b is 5 base, we need to find out the value of this number 1010 in decimal. So what is the answer? Answer is 1 into 5 cube. That is 0. So 1 into 5. 125 plus 5. The answer comes out to be 130. Okay, simple. But actually, this question has a technical problem. This question is actually wrong technically. Why? Because if you are taking base as 5, if you're taking base as 5, you cannot write digit 6. But Z actually made a mistake while making this question. They did not think that this question is technically wrong, because if you're taking base as 5, you cannot write 6 here. Logic is correct, but actually mathematically it is wrong. Okay, answer is correct. Answer is 130. I hope you thought of also, okay, how come the base be 5 if the digit is written 6? Your doubt is genuine, but Z has made this mistake while making this question. Do not worry. Okay, come to the next one. Two positive integer a and b. If a plus b raised to power a plus b is divisible by 500, then the least possible value of a into b is, that should be multiple of 500. Two positive integers. Now two positive integers, the sum of two positive integer can be a multiple of 500 only when the sum is at least 10. The sum is at least 10, then only the 10 raised to power 10 can be multiple of 500. Now, can you thought of any other number in which the number is multiple of 500? Small number? 9 raised to power 9, obviously not. 8 raised to power 8. It is not possible. No? The digit should be at least 0, then only it will be a multiple of 500. So that is the smallest number that will satisfy this condition. So what we need to find out? Least possible value of a into b. A plus b is 10, and if sum is constant, we know how to maximize the product. Maximum product will be when both the numbers are equal. But here we have to minimize. The product will be minimum when both the numbers are as far as possible. So I'll take one number as 1 and other number as 9. So minimum possible value is 9. The maximum value possible is 25. But we need to find the minimum. So answer is 9. That is the answer. Easy question. That is also easy. It's a perfect cube. 11 raised to power p plus 7 into 7 raised to power q minus 2 into 5 raised to power r plus 1 into 3 raised to power s. It is not 5, it is s. It's a perfect cube where p, q, r, s are positive integers. Then the smallest value of p plus q plus r plus s is. We need to find out the smallest value of these integers. To make it perfect cube, every power, because every prime is a different prime, so we need to make it every prime as a perfect cube. So to make it perfect cube, p should be how much? They are positive integers. So this number should be at least 9. So if p plus 7 is 9, the minimum possible value is 2. Now here, do not try to make 3. Can I make it 0 as well? If I take 7 raised to power 0, then also it should be a perfect cube. Na? So here, that is, I'm taking 0 power. If I'm taking 0, then q will be 2. Again, it is coming out to be perfect cube, मतलब positive integer. This, obviously, I have to take it at least 3. No, I cannot take it 3, otherwise r plus 1 is 3 now, so r will be at least 2, correct? Can I take it as 0? No, I cannot take as 0 because they are positive integer. So s, I have to take it 3 at least. So these are the minimum possible value of p, q, r and s. And what is the answer? Answer is 2 plus 2 plus 2 plus 3. Answer is 9. So again, I think till now you have seen many questions, not very difficult question based on number also in Z. So Z is considered to be tough. Matlab exam, it is not actually. Geometry is slightly tougher, but rest of the topics are pretty okay. Come to the next one. And this question, x and y are digits at the unit place of the number 408x and 789y, where x is not equal to y. However, the digits at the unit place of the number 408x raised to power 63, that is in power, and 789y raised to power 85 are same. The unit place digit is same. X raised to power 63, the unit place of this number and unit place of this number is same. What will be the possible value of x plus y? Now, if you know how to find a unit digit, I'm sure you know how to find. We divide the power by 4. So what is the remainder here? Remainder is 3, and whatever the remainder is, we multiply unit digit at as many times to finally find the answer unit digit. So unit digit of this number is actually x cube. And what is the remainder here? Remainder is 1. So unit digit of this number, it's y. And the question says both the unit digits are same. So x cube is equal to y. If x cube is equal to y and x is not equal to y, so I cannot take 1 because 1 cube will be equal to 1. In that case, 1 and 1 will be same. X should not be equal to y. I cannot take 4 cube because if I take 4 cube, this will also be 4. So what I can take? I can take 2 cube. So this becomes 8. I can take 3 cube. So this becomes 7. I cannot take 4 because 4 cube will be 4. I cannot take 5 because 5 cube again will be 5. Unit digit we are talking about. 6 cube will end with 6. And 7 cube I can take it. 7 cube will end with 3. And 8 cube will end with 2. The unit digit are these many. Okay. I cannot take 9. 9 cube will also be 9. What is asking? Asking what is the value of x plus y? If I take 2 and 8, again this will be 10. If I take 3 and 7, this will be 10. 7 plus 3 will also be 10. Or 8 plus 2 will be 10. So what is the answer? X plus y, the only possible answer is 10. In all the cases, the answer will be 10. So simple question, find the unit digit and put it equal. Okay, one more question. Question says, David has an interesting habit of spending money. He spent exactly X pound on X day of the month. For example, he spends exactly 5 pound on 5th of any month. On a few days in a year, David noticed that his cumulative spending during the last 4 consecutive days can be expressed as 2 raised to power n, where n is a natural number. What can be the possible value of n? Now 2 raised to power n. So the sum of any 4 number can be at least 10. So the spending can be 16. The spending can be 2 raised to power 5, which is 32, or 64, or so on. 128, 256, or so on. Okay. Now this is not possible because the 4 month, the maximum digit can be 31. So the 4 maximum sum can be only this. So this cannot be equal to 128. This has to be less than 128. So this sum and this sum is not possible. So we need to just check for these 4 numbers. Can I get the value of 16 anyhow? 4 consecutive number. The minimum is 10. To get 16, the average should be 4. So if I make it hit and trial kind of thing, 3 plus 4 plus 5 plus 6, that is 11 plus 7, that is 18. And if I try to take it lesser than that, 2 plus 3 plus 4 plus 5, the answer will be reduced by 4. So this will be 14. So it can never be 16. Similarly, if I look for 32, the average is 8, right? If I look for the numbers 7 plus 8 plus 9 plus 10, that is 19 plus 15, that will be 34. And if I take it one lesser number 6, 7, 8, 9, the answer will be 32. Again, not possible. If I take 64, the average is 16. So let's say 15, 16, 17, and 18. So that is 16.5 is the average. 16.5 into 4 comes out to be 66. If I take the lesser value, then this answer will be 62. So again, it seems this is also not possible. But here it is not mentioned that you cannot take the dates of next year, next month as well. This is not possible any of the case. But look at like this. If the dates are 30th and 31, this makes 61. And if I take the next two dates, where of next month. So the four consecutive days can be 30th and 31st of the previous month and first and second of the next month. So four consecutive days and the total spending will be 64. So the only possible answer is that is 64, which is 2 raised to power 6. So what is the value of n? The value of n can be only 6. No other value will satisfy. You cannot write 32 in this manner. So I can take 31 plus 1, but next 2 days I cannot write it like this. Getting it? You cannot take it 30 plus 1. The next date will be 2 and 3. So no other value is possible except 64. So answer is 6. This is a good question. Okay. And I'm sure that I have covered all the questions based on numbers. Yeah, I have covered all the questions based on numbers in this session. So next session, which is coming, it's trigonometry. Probability I've already covered. I'll post it both the videos. And for more videos, subscribe this channel. Okay, I'm going to take certain more videos of similar kind. Thank you.